As a naturally curious species, we have watched the heavens since we first looked up and noticed those sparkling dots that move around the night skies. When we cobbled together the first optical telescopes, we were able to see things in a little more detail and became even more curious. In the centuries since, we have built observatories in high places to try and overcome the limitations of seeing through the Earth's atmosphere. We have also tried observing using wavelengths other than visible light, such as infrared and radio astronomy. Once we were able to send substantial payloads into Earth orbit and beyond, we faced the possibility of putting a telescope in a place where it would be unaffected by our atmosphere and be able to see better and further than we had ever managed up till now. Putting a sensitive instrument like a telescope into space is no trivial matter, but through trial and error and some persistent and creative engineering, we have managed to put several quite sophisticated devices into space, and are seeing things that both confirm and confound some established tenets of astrophysics. The Hubble Space Telescope. Launched by NASA and the ESA, the European Space Agency, in 1990, it is positioned in low Earth orbit, or LEO. James Webb Space Telescope, or JWST, is launched by NASA in 2021, and it's positioned at the L2 Lagrange point. More on that in a minute. The Solar Heliospheric Observatory, or SOHO, positioned at the L1 point, is another joint project between NASA and ESA. The Chandra X-ray Observatory, launched by NASA in 1999, this one is in a highly elliptical orbit. The Transiting Exoplanet Survey Satellite, TESS, launched by NASA in 2018, it is again in a highly elliptical orbit. These telescopes cover a range of frequencies and are used for various astronomical observations, including studying planets, stars, galaxies, and other celestial objects. Here's a little more of a breakdown on each. Hubble. The Hubble Space Telescope, launched in 1990, is a joint project of NASA and ESA. It orbits around 332 miles above the Earth, providing a clear view of the universe free from the blurring and absorbing effects of the atmosphere. It has a 2.4-meter primary mirror and is equipped with cameras, spectrographs, and fine guidance sensors, allowing it to observe visible, ultraviolet, and near-infrared light. Hubble has made more than 1 million observations. Hubble has played a key role in the discovery of dark energy, revealing details of gamma-ray bursts, and studied the atmospheres of planets revolving around stars similar to Earth's sun. It has also observed comets and planets, providing valuable insights into our solar system. James Webb. The James Webb Space Telescope, or JWST, is a space telescope designed to conduct infrared astronomy. It was launched on December 25, 2021, and is the largest and most powerful space telescope ever launched. Unlike the Hubble, which is in low Earth orbit, the JWST operates at the second Lagrange point, or L2. This location allows it to stay in line with the Earth as it moves around the Sun. The L1 and L2 Lagrange points are specific regions in space where the gravitational forces and the orbital motion of a body balance each other out, allowing a smaller object to effectively hover in a stable position relative to the two larger bodies, such as the Earth and the Sun. The JWST is equipped with a 6.5-meter diameter primary mirror to collect and focus infrared light, a sun shield to keep the telescope cold, and 4 scientific instruments to conduct its ambitious science operations, including the near-infrared camera, near-infrared spectrograph, the mid-infrared instrument, and a fine guidance sensor with tunable filter module. The JWST has 4 key goals: to search for light from the first stars and galaxies that formed in the universe after the Big Bang, to study galaxy formations and evolution, to understand star formations and planet formation, and to study planetary systems and the origins of life. SOHO. The Solar Heliospheric Observatory is a space telescope positioned at the L1 point. It's a joint project between NASA and ESA. SOHO was launched in 1995 and has been operational since then. Its primary mission is to study the Sun, and it has provided valuable data for space weather forecasting and has significantly contributed to our understanding of the Sun and its impact on the solar system as a whole. Chandra. The Chandra X-ray Observatory is a space telescope launched by NASA in 1999. It is the most sophisticated X-ray observatory built to date, and it's designed to observe X-rays from high-energy regions of the universe, such as the remnants of exploded stars, clusters of galaxies, and matter around black holes. Chandra has made numerous important discoveries, including the first unambiguous evidence for a black hole. TESS, the Transitioning Exoplanet Survey Satellite, is a space telescope launched by NASA in 2018. It's another one in a highly elliptical orbit and is designed to search for exoplanets using the transit method, which involves detecting the small dips in the brightness of a star as an exoplanet passes in front of it. TESS has discovered numerous exoplanets, including a wide variety of planet sizes and compositions. Its mission is to find small, rocky planets in the habitable zone of their parent stars, where conditions may be right for liquid water to exist. With these eyes in the skies, we not only have many new, awe-inspiring images of the surrounding universe, but are starting to gain real insights into how things actually work out there, and if there are other planets similar to Earth, with the possibility that some of these may actually have other living things on them. Hey, thanks for watching. Check out the links below, and we'll see you next time.